So welcome to the Engineering Room, a monthly series of long-form conversations with influential people from the software world. The Engineering Room series is sponsored by Equal Experts, and I'd like to thank them for their ongoing support. So if you'd like some help building some great software or are interested in finding a great place to work, do check out their links in the description below. I first came across the work of today's guest when he published what I think is the best book on software design ever written. At least the best that I've ever read. His is the design book that I wish I had written, though he did a better job than I would have done. It resonated very strongly with me when I first read it, providing language that helped me to better express how I thought about software design and introducing me to ideas that I hadn't thought of. I put the book Domain-Driven Design at the top of my recommending reading list for software developers when I made a video on that recently. Later, our paths crossed often enough on the conference circuit that we became friends. As well as writing my favourite design book, my guest is also an internationally renowned and thoughtful expert on software development in general, always worth listening to. He's also a great conference speaker and, as we English would say, an all-round nice chap. So he sent me his reaction to a recent video of mine on the use of AI co-pilots in coding, and I couldn't pass up the chance to invite him here to join me in conversation. Please welcome my friend and guest today, Eric Evans. Hi, Eric.
Hi, Dave. Thank you for inviting me.
It's my pleasure. Thank you for agreeing to attend. So I definitely want to get to talking about your interest in AI, because I think that's something that we're all interested in these days. But I also couldn't pass up the chance of us talking about domain-driven design. My impression is that there are some people that approach what we do from different angles, and I think of myself primarily as a designer rather than a coder. Obviously, I don't make a big distinction, if I'm honest, but I think that primarily that what we're doing is about design, is my view. Could you give us your elevator pitch for domain-driven design and why you think it matters and what's important?
Right. I agree that design is much more at the heart of what we do than programming. The code itself, I do think that those skills are important skills, and I've talked about why I think that. But if I were to try to distill domain-driven design, as I have tried to do many times, and I think that it is not a thing that distills into, like, a few bullet points very well, but one of the kind of unusual aspects of it is the focus on language. So where there are many design approaches where we talk about abstraction and finding concepts that represent the domain in useful ways and useful interactions, and all of that is very important in domain-driven design. But I think a kind of unusual aspect of it is the emphasis on finding the right words for those concepts, finding the right language to describe the interactions that happen in the events and so forth, so that eventually you have a kind of language that very concisely expresses the domain problem as you understand it and the way you intend to solve it. And this would run through all the way from the way you talk about this with the business people, the domain experts, through the design and into the code, which is one of the reasons that the coding level skills matter so much. The ability to actually express something like that takes a fairly good level of programming skill. It also takes a language that is able to have those kinds of expressions, which most modern ones do. And I think that, as we call it, the ubiquitous language that cuts through those different levels, that's probably the most prominent feature.
And that resonates strongly with me. So one of the techniques that I recommend to people as part of the stuff that I do is using acceptance tests to drive our development process. So we come up with examples of what we'd like our software to achieve, and we express those in the ubiquitous language of the system. And one of the techniques that I like a lot is to actively try and create an executable version of that ubiquitous language that allows me to easily script these scenarios that tell me what my system's meant to do, and then I'll develop to those things. And that link in what you're talking about between the language and the way in which that language helps us to think about the problem, I think is deeply important to be able to better understand the problems that we're going to solve and better position us to solve them.
Yes, I mean, the thing you mentioned about the test, so one thing that was clear to me even at the time is that the tests that we write are an important artifact that needs to be in that ubiquitous language as well. So if
Yes.
the tests are written in one language and the underlying code is written in another, you might argue, well, you still know if the answer is right, except you don't really, because you don't know if the question is the same. When you write a test, you could say, this test is a statement of a question and the expected answer. Well, if you're not using the same language as the underlying system, how do you know that you've understood that question? I mean, of course you can. Of course you can, and people do it all the time. But that is another thing, hopefully, that people realize is that I'm sure neither of us is talking about getting that language right and then writing our tests and then writing the system. We're talking about this as all iteratively evolving in parallel. The tests would be written before the code, but both of them would be crude first passes at the test suite and the solution and the ubiquitous language. And then the insight you gain leads you to refine all of those things again and again until you have something that really, that's one of the ways you know that your ubiquitous language isn't quite right. If you are having a hard time expressing something either at the test level, like it's hard to express the problem statement effectively when you're writing your tests, you say maybe something's wrong with the language that we're using. Or if your solution is hard to express, which is the code that makes the test pass. These are all, for me, central clues that the language needs refinement. And this constant return to the language, I think, is one of the more distinctive aspects of domain-driven design.
Yes. Yes. And I don't know whether you'd agree with this, but my impression is that one of the reason why that's so important and why it works is it kind of helps us and also forces us to separate what it is that we want to achieve with our software from how we're going to achieve it. And we use the what it is that we want to achieve to shape our designs that then makes it more easy for us to achieve it.
I think there is a separation there, and that separation is very at the heart of the test-driven and continuous delivery kind of stuff. To me, I think that the emphasis in domain-driven design was more on the things that unify those, which is that there's a language, and that language, like we're speaking English right now. English can express all sorts of things. It can describe, among other things, it can describe problems and it can describe potential solutions to problems. The ubiquitous language that you develop on a project is a much more constrained kind of language, and yet it still needs to be broad enough to describe those two kinds of things. Sometimes the sort of manifestation of that language in an artifact will be quite different. Like you write a document that tries to describe some of it, you're just sort of describing it in English, in structured English. You go in and write tests in some kind of test framework, And that code will look quite different than the code that you're using to build the solution. And it'll be focused on a different subset of the language. But I would view it as still the same language, because part of, that aspects of that language enable you to state a problem. Other aspects allow you to express a solution. But they still need to be the same language, or else there's ambiguity in there.
Yeah. So how do you see what is it about DDD that helps us to do a better job then in doing this? So I think you're talking about the certainly your book talked about the importance, with profound importance, of minimizing impedance mismatches between different groups of people thinking about the problem from different angles, so that when the business are talking about the problem, they're talking in the same way that when the technologists are talking about the problem, and so on. But I think that what we're talking about is going a little bit further than that in terms of this use of language.
Right. We've been talking about sort of the part of it that we do.
Yes.
I would say that, yes. So the first thing that, and this is one that I think a lot of people understand, is that it's important to use the same language when we are working on our design that we use when interacting with our domain experts, because otherwise you get these misunderstandings. They describe the problem in a certain way, and then we describe it in another way. And we think that those are equivalent, but they may not be. So this was a common, and even it was even advocated when I was starting, that the analysis work would be a truly distinct model from the design model. It was called the analysis model and the design model.
Yeah.
And they should be different. And that this was a positive thing, because the analysis model, and I see the logic of it. At the time, I just bought it because, when you're just learning, when you're starting out, so the analysis model would be optimized for the way the business people think. And then the design model would be optimized for the software that we were going to write. And I find that doesn't work very well. If you create two different models, then you have this just this constant confusion. Now, it's funny because I also advocate, and this is a big part of domain-driven design as well, that we should not have just one model in a complex system. We should have many very distinct models separated into bounded contexts with translation in between. And so why am I so okay with that translation and that distinction, but I'm not okay with this one? The reason is because the level of collaboration that I expect, the level of one team working on one system, one solution, and even understanding the problem together, this creative collaboration that I want to bring about doesn't happen if you don't have a common language. Whereas the bounded contexts are to separate different efforts at different solutions. So, it's still great to have cooperative relationships and so on, but we're saying, yeah, we're going to really work closely with these people. If we're going to work that closely with some business people, we need to speak their language. And what used to happen was certain people on a team would get good at talking to the business people. I was usually one of those people. I would learn enough to have intelligent conversations with the business people. Then I would go over and talk to my colleagues, and I knew their language too. And I could map between the two better than most, maybe, but it still didn't work very well. And what would tend to happen is that as I went back and forth in these conversations, I would start to, and this was just something that kind of happened, but I would start to draw the two languages together. I would say, we call this something. And they'd say, well, the reason that doesn't make sense. The reason we call it this is because this is what we do. I can remember more than one occasion where we would get to that point and they would explain why the language was different, perhaps, and that would lead me to this, aha, no wonder we've had so many edge cases.
Mm-hmm.
Just the ridiculous number of edge cases that we get sometimes. Often
That's missing some concept in the problem domain and the distinction between different parts of that.
Or a misaligned concept, right?
Yeah.
You just have a concept that's similar to, but not quite the same as
Mm-hmm.
the concept they're using. Most of the domains that I've worked in have, not all though, but most are sort of where the domain itself is pretty abstract. So like finance, I did a lot of financial work when I was starting out. In finance, the whole thing's made up to begin with. So in one way, you have a completely abstract domain, and then you map it to a completely abstract software solution, And so then you really are thinking in terms of how do these abstractions fit with those abstractions? And the same is true in other businesses, but sometimes there's a physical dimension to it as well. So, a lot of the examples in my book revolve around a shipping domain. And that's really fascinating because there are layers of abstraction, and those businesses operate on systems of abstraction as well. But down at the bottom of all that is some physical reality. And it pokes through sometimes and places constraints on the abstractions that you can use. So all of this is why you need to align the model. And in order to do that, you need to align the language, because it's probably not theoretically, mathematically necessary, but we humans can't, I don't think, do it without, aligning the language.
It's interesting. Your comment about finances, I found slightly amusing because I had a friend when we worked at LMAX. One of the guys, Andy Stewart, who worked there, was absolutely brilliant at just explaining things, and he used to bring all finance down to selling cans of soup, basically. So you could describe. He used to describe complex derivatives and trading complex derivatives in terms of selling cans of soup and all this sort of stuff, so that everybody understood it, which I thought was brilliant.
Oh, I love derivatives, actually.
Yeah.
Yeah, I mean, I really do. I think I enjoy finance because it is one of those sort of infinitely complex domains, and because so much of it is artificial, and it is true that there is a level at which we're distributing the soup cans,
Yeah.
deciding how many soup cans do you get and how many soup cans do I get, and that is there, but there's so many layers, and that part is so arbitrarily decided in the first place. I think it's fair to say that it is a mostly, I don't know, synthetic domain, that it's evolved over, millennia, but it's still a creation of human minds.
Sure, I guess I was just absolutely. We were layering a model that worked for us to help everybody to understand what it was that we were doing and to have more intuitive understanding. I do that with physics. My hobby, as you know, is I'm interested in physics and so on, and so stuff that I don't understand properly, I kind of imagine the models. Yeah.
And you put some potatoes in there. Those are the protons. And just picture you make everything a metaphor about soup.
I shall try that from now on. I think
Before we
that
go to
one of
the
the things,
big,
we've been talking so far about the kind of, the business focus of domain-driven design, and I think that's important. But I think there's another aspect that, to me, it seems it's still relevant. I'm an old school OO programmer. That's where I kind of cut my teeth. And one of the light bulb moments that I had with when I first learned about object orientation was that I was kind of modeling something, when I was building the software. The links between the pieces was almost as important as the logic in the pieces very often, and the interactions between them. And so it seems to me that people often seem to miss what, to me, seems obvious, that domain-driven design is equally applicable to more technical code that we write. It's just that the domain's different. If you're building a list, there's a list domain. There's something about the behavior of lists that's part of the problem domain.
Yeah, I would say, like, to broaden out a little more than that. And I know that you were involved in all this high-speed messaging and
Yeah.
the infrastructure things. And that's a domain. It even has some physical constraints. Like, it's a domain where the way the machine actually works sometimes matters. So you could imagine a beautiful, elegant abstraction of a message, and then you would say, but that's not how machines work. That would be
Yes.
extremely inefficient if you implemented it that way. But so, yeah, the domain, that's why I call it domain-driven design and not business-driven design or something.
Yes. Yeah. So what you're referring to, we referred to as mechanical sympathy, understanding enough
Yes.
about how the
Very
hardware
nice
worked
term.
to put our designs into the context and take advantage of the hardware.
Yeah, and when you're pushing the limits of what the hardware can do, which was what you were doing.
Yeah.
What was the name of the project that you were doing that on?
So the company was called LMAX. That we built the software for. We were building what turned out to be one of the world's highest performance financial exchanges. It was
Yes.
a huge amount of fun.
It always sounded like tremendous fun to me.
Yeah.
And I always thought, although I am fundamentally not a kind of down in the bits guy, and not a technical frameworks guy, but on a project like that, I think I could actually get into something like that, because to make something like that work, you need a model, and you need
Yes.
and then you hammer that model, understanding the constraints that you're working under, which are severe, because the mechanical sympathy thing. This mechanical sympathy thing just doesn't really matter if what you're doing is tracking 100,000 shipping containers that each take weeks to be transported from one place to another, and each of which has maybe a few thousand events. And then we're in a realm where modern hardware can handle it so easily that, within reason, there are things I could do that would be so stupid that it would be non-performant. But within reason, I should be okay.
Yeah.
And not everything I've worked on is like that. There are situations where I get into monstrous, performance problems. And that's one thing I picked up from this mechanical sympathy thing. I mean, I think it had been there in the work I was doing, but I realized that sometimes it can be a wonderful clue that the model you're using. So let's say you're doing something that doesn't seem intuitively like it should be all that slow, but it is slow.
Yeah.
And you think, why is my intuition about this so wrong? Well, one likely thing is that the mechanical sympathy is misaligned. You're doing things in a way that's very unnatural to the mechanical device that you're using. But also, what I've found is that more often than not, if you find a model that resolves that, it's usually a better model of the domain too.
Yeah, absolutely. One of the facets that I think was that in some ways I enjoyed most and was most proud of the system that we built at Telmax was that it was intensely a domain-driven design solution. So what we ended up doing in large part was building infrastructure that was blisteringly high performance and used all of the techniques of mechanical sympathy to be able to focus on those, but with very strong separation concerns from the domain logic of the system. So the actual bits of the software that were focused on the trading algorithms and so on, executing stops and all of those kinds of things in our exchange were kind of pure domain logic. That they were almost that simple. So our services were single threaded and rich. The state of the system was represented by the in-memory state of these very high performance services, but we just communicated with them so blisteringly fast, and they operated quickly enough that their performance was almost negligible in the measurement of the system because everything else was so fast.
And you could just express what that
Yeah.
logic was,
Yeah, so
isolated
so so
from
so
the other
a
concern.
trade comes flying into the execution engine and goes into a stateful marketplace, and does it match or not? And you put a record out to say whether it matches or not.
Yeah.
That was
And so, by the way, I mean, one of the principles in domain-driven design, not as central as what I was talking about earlier, but this is an illustration of how the principles are a lot broader than the examples in the book. The examples
yeah,
in the book are rooted in 2003 or so. But so what you just described to me reminds me of the layered architecture. And so the layered architecture in the book is described with the example that, well, we have, the distinction between the database layer, the domain layer, the application layer. But here you've got a completely different set of layers. But the point of it is that you have a way of isolating this piece of domain logic in an
yes,
environment where it can do its job, you know. So like if you were to do what people conventionally did back in the 90s and 2000s, and probably a lot of people still do, where these business activities are anchored tightly into a database transaction.
yeah,
So there's no real separation between the domain layer and the database. Um, this places a lot of constraints on the kind of logic that you can create, that the kind of model you can use, how performant it will be. So that was the example that was used in the book. But here you have a completely different architecture,
yes,
completely different concerns. But one of the features it has is that you can isolate a little piece of domain logic from all the machinery, and yet it can do its job in a really clear, distilled way and in a high performance way.
yes. And if we take that broader view of domain, so we can talk about the communications domain in our system, and the persistence domain as being separate concerns of our system, that we, as well as the business logic, the logic of trading, and each of those is distinct enough and collaborative enough with its near neighbours that it's high performance, but also has a great separation of concerns so that it's focused on one part of the problem, which I think makes it easy to understand the problems, easier to write the code, easier to test the code, and you end up with these blisteringly high performance results, I think, as a result of those better kinds of design, what I think of as, anyway.
Yeah, and this was kind of such a wonderful eye-opener for me, probably a lot of people, when you guys started talking about this publicly and really said loud and clear that the path to this super high performance isn't about going low level in the programming. It's not about doing all this stuff in assembly language and whatever, which was kind of like people said, if you need to go fast, you need to let go of the high level language, let go of all the abstractions and so on. You guys were saying, find the right abstractions, find the
Yes.
abstractions that align well with what the machine, how the machine works and what you're
Yes.
trying to do, the mechanical sympathy. And that was a big aha moment for me. And I realized, oh, yeah, domain-driven design now can move in, my style of development can move into territory where high performance is necessary. We don't have to stick to the, slow stuff.
Yeah, and I think you've said some things about the synergy between architectures like event-based systems and so on with domain-driven designer's approach. I think it's broader than that, but I think you're right. What we're seeing is that this is a generally applicable approach.
Yeah. Well, yeah, and I mean, like, I said, okay, the shipping domain where you have 100,000 containers to track and they do 1,000 things in their lifetime over a period of weeks. And that's low volume, and of course it is. And yet, even with that, you could create performance problems. Suppose that you had to call up, 1,000 records from a database, and you do it one at a time.
Yeah,
Like, suppose that you wrote some object-oriented code and it calls this thing, and every time it goes through this loop, it goes and gets the data that it needs, and that happens to be in a database, and that might be on the other end of a wire for all I know, because it's also abstracted away. And so even calling up, 1,000 containers to do some kind of inventory or something could be disastrously slow. You have to think about these things, and then you
yeah,
have to choose a model. So then you could say, all right, well, let's have caching. Let's
yeah,
just cache all the containers, but you don't need to do that first. What you need to do first is you need to think about, well, what is it I'm trying to do in terms of the domain that involves 1,000 containers? And maybe we need a name for this group of
yes.
containers. Like, what are these 1,000 containers? They're not just 1,000 randomly chosen containers. There are something or other. And if I know that much, I could do a single database query to get the something or other in
Yeah,
one
it's
shot.
it's identifying and drawing those lines of abstraction that allow us to have those higher level conversations between the pieces.
Yeah, and so it's no longer just a list of containers that now takes 1,000 database hits, but instead it's a single, whatever, warehouse inventory or something.
Yeah, which gets me to, I think, if you'll forgive me praising you too much, but probably the most brilliant part of the domain-driven design book is kind of the strategic design patterns. I think there's some real genius, a real insight in there. The idea of bounded contexts, it was so clear to me when I read about it, and yet I hadn't thought of it before in that way. It was just fantastic.
You make me blush a little, but I am kind of proud of ubiquitous language. I think of all the things in the book, it's kind of fundamental. I think it's one that applies.
Yeah,
It's hard to think of a situation where that one doesn't apply. And I think a lot of people have not quite gotten it. I think that people conflate that with what I would call a subdomain, like carving a big complex domain up into, like, so if we're talking about shipping, well, we could talk about booking shipping, and we could talk about the logistics of loading, and all those separate domains.
yeah,
And the reason this is so confusing is because it does correlate with that, because we tend to apply it as a tool for managing, keeping those things separate. But it's more fundamental. I think you have to have bounded context if you want to have any kind of rigor at all. Is basically all it says is you need, if you want to define a term clearly, if you want a language without too much ambiguity, you need a boundary within which you can say, this is the context within which I'm using this terminology. and therefore I can define it. You know, you can't define a word without a context.
Yeah.
And so I stuck the word bounded on there because unlike normal English, normal conversation, where we're implying the context as we go along, you know, I'm constantly updating as I listen to you. I figure out as you say words, and I know there are many meanings to almost every word you say, and yet I know which one you mean because I have a context in my that I keep updating based on our conversation. That's great, but you can't write a software system that way.
Yeah.
Or you know, you need to be able to say, well, here's a subsystem that we're building, an actual piece of software that we're building. Within this limit here, this is what these words mean. And
Yeah.
that boundary, we make these things all the time, but we didn't have a good name for them. So I'll take a little credit for the name.
I think that one of the things that we're kind of talking about implicitly is going back to where we started talking about the importance of design, is that, you know, this idea of that there are places in the structure of the software that we create that are somehow more important than other places, and those are the joins between the pieces, those boundaries between the different bounded contexts, or, you know, interfaces between services or components of the system, and worrying a little bit more carefully about those places seems like a good strategy to me.
Absolutely. I mean, those places are important in part because they're so tricky.
Yeah.
And, you know, there's all sorts of ways to address that trickiness, starting with being really clear about the fact that they're there, you know, that we have this seam between two things. So just being more explicit about what's going on really helps. Another thing is if you've got something really tricky, you realize, I mean, I've seen situations where there was a really important piece of logic where that was handled in the interaction of two systems. So that
Yeah.
the systems integration effectively was doing business logic, doing high level business logic. I mean, I think there's often a little bit of business logic mixed in, but I'm talking about something non-trivial and important. And one of the solutions was to move that business logic either into one of those or into a third context where
Yeah.
we could really make it explicit and coherent, and then have more but simpler and cleaner integrations, you know, so that you have kind of, I mean, what you really would like to have is that these tricky inter the tricky communication between bounded contexts is in concepts that are sort of easy to translate, easy to coordinate around. You don't always
I,
have.
I know, I know that kind of, I think that the book was written with kind of the assumption of object-oriented development as an approach. I know that you have also done a fair amount of functional programming from our conversations together before. Do you think, I've heard people say things like domain-driven design is an object-oriented technique, and it seems like more than that to me. What's your view?
Yeah, I do not think domain-driven design is limited to objects at all. I think, though, that I will acknowledge that the examples in the book are highly object-oriented. So when people read the book, they need to factor that in, right? That the examples are drawn from the typical, you know, software architecture and languages of the early 2000s, which was a period of object-oriented hegemony. I hope we never see a single paradigm dominate like that again. Even in my book, I talk about other paradigms. I talk
Yeah.
about them somewhat speculatively, but and I think that I was wedging some functional concepts into the object-oriented design as well here and there. Yeah, it totally translates, but what you have to do is not worry about like what's an object and a method and overly literally map things over, but you think, is this whatever programming language I'm working in, can it express abstractions? And what are those abstractions like? Those kind of abstractions will definitely influence the kind of model, the kind of domain model we come up with. It's kind of like mechanical sympathy in the sense that you can't completely ignore the machine that your software is running on if you want it to perform very fast. Well, you can't completely ignore the nature of the programming language that this is going to be implemented in when you're modeling the domain. So I'll give an example of when I, so for a while I was really into Clojure, which is a dialect of Lisp for those who might not know. And Lisp, as the name implies, is all about lists, and everything's a list. And so if you really want a nice, elegant domain model that works well in Clojure or another Lisp, you kind of want to look for the lists, the sequences. And so I was working on this email analysis application. I'm sure that if I had been writing it in Java or Smalltalk or something, I would have been zeroing in on certain entities and methods and all that stuff. But instead, I was realizing, well, first of all, the sequence of messages fits really naturally into the basic paradigm of Lisp. And then also, we're going to have transformations of this list, and each one of those is going to have a name, and it's going to have to mean something. And so you start to develop a domain model. It's all about like lists that have names and transformations of lists into other lists that also the transformations have names. And it becomes just as conceptual and just as domain model-y as an object-oriented one. What I do see a lot of times is that people start to bend these languages into OO languages while constantly dissing OO. They will add OO things, but they'll say, oh, this isn't an object, it's a record. And that's not a method, that's a whatever they call the thing that operates on the fields in the record and yet allows you to ignore the content, the structure of the record at the same time, but not a method.
Yeah.
I still like OO, and I really like functional too. It's not a, anyway, I'm rambling a bit, but absolutely, DDD is not about objects as such. It's just that the world was dominated by OO when I wrote my book. If I had written, I wouldn't have been thinking about it anyway because the world was OO. But even if I had written my examples in Lisp, nobody would have been able to make heads or tails.
Nobody would have bought the book.
If I had written something in 2015, I could have written examples in Clojure, and a significant population would have been ready for that.
Yeah.
But also, I'll give a little more credit than that. I think that the philosophy of collaborating with your domain expert colleagues, evolving a model that is aligned closely with a language, that whole thing emerged, I believe, emerged in the Smalltalk community. That's certainly where I picked it up, where it was just sort of the norm, or kind of the way we do things in that community. Highly iterative, highly collaborative. The idea that the code should represent a model of the domain was not a given in those days and was in the Smalltalk community. Now, the kinds of models that people tended to use, they were, I think, much too sort of literal minded.
Yeah, I guess there's a sort of philosophical link in that, you know, the roots of object orientation came from simulation, really, and you could think of one way of thinking about domain-driven design is kind of a simulation of the problem in software.
Some are, right? I mean, like there
Yeah,
is an aspect of simulation in some domains, but in others, the simulation is, I think it's fair to say it's inspired by that. And then there are different kinds of models, some of which are very simulation oriented and some of which are not so much.
sure. So let's move on from looking back at your book to the thing that triggered our conversation, your email to me about your interest in AI and LLMs and
Oh,
programming.
yeah.
So so where do you think we are now with the use of LLMs, and where do you think we're going?
Well, I mean, where we are now, I think, is definitely the thing that always, the only comparison I can come up with is like the late 90s, you know, with regards to the internet and the World Wide Web, when that was a new thing. And if you look at a website from 1996 or 97, or when did the web actually start as such?
Earlier than that, so I think I think I had my first web. I downloaded my first web browser in about 93, 94.
Yeah, you were way ahead. And I pick years like 96, 97 because I don't think we're in the 93 stage where that would be like a couple of years ago with LMs where the people in the inside of the
Yeah,
world that created these things, to them, these have been around for a few years and they've been using them. I think that I think some of the AI people were surprised by the reaction that ChatGPT got, but it was the first time that most people had had a chance to really see one of these things. I remember maybe a couple of years ago, Microsoft put a fairly smart bot up, but they had made the mistake of making it like learn in real time. And so naturally everyone taught it to be racist and so on.
yeah,
And so they took it down, and then everyone was afraid. This is my theory, my unsupported theory about why we didn't see much of what was going on. And then all of a sudden, ChatGPT, you know, is revealed, and it's like, wow, the average consumer can go and fiddle with this thing, and it can do amazing things. Or a person like me who's seen a lot of software, and I'm just like, wow, this is the first time I've seen a thing called AI that feels to me like it deserves that name, like it acts like it has some actual intelligence.
yeah.
So I think in that sense, and now we have all these, we've got the flowering of a lot of people having access to it. That's like after the World Wide Web and the internet became public and people started getting access. So that's 96, 97 at the earliest. And I think that's where we're at. And if you said in 1997, well, where is this whole web thing taking us? You could have speculated, you would have gotten some broad brush things right.
Yeah.
I think I would have predicted that it was going to be in everything, and I would have been right. I think I might have predicted that in the future, I'd have video chats with people in England and it would be carried by the internet. I don't
Yeah.
know if I'd have predicted that or not, but it sounds plausible. Um, but you know, there's a lot that I wouldn't have predicted. So obviously there'd be a lot of things. Anyway, the transformative nature of it, but also the early phase we're in. So when bringing it more grounded, I was developing software on multiple projects in the late 90s and early 2000s at a time when people were coping with a very specific problem, which was you take this platform, which was designed for documents and hypertext. Hypertext, no one used that word anymore, by the way, although we all use hypertext all the time, every day, but we don't use the word anymore. Isn't that funny? But I
It is.
digress. The World Wide Web was designed for interconnected documents. But what people wanted to use it for was applications. People wanted to be able to put, a flight booking app on the web. Well, just putting up like a form that you could fill in a few data fields and submit that, and that would be stored in a database. That was a non-trivial activity.
Yeah.
It sounds funny even to say that now because, it's just so extremely easy now. But through the late 90s, I was on a series of projects where we were doing things like that. And before then, I had always been I was always on enterprise software, anyway, I was on a lot of projects. Remember, before that came what we called the fat server, where a computer, like a PC with fairly hefty computing power would do most of the actual logic work. The persistence of data would be on a server. So the data connection was really about taking persistent data or coordinating between computers. So
The client devices were just kind of I/O.
yes. And now, right, I mean, in a web page, the web page is just, the UI part and maybe the application part. So anyway, I don't want to go into a lot of what we did, but I will say this, that it was very hard to make a practical application on the web in the late 90s. And people created frameworks for doing this. And those frameworks didn't always make it better. Those frameworks were clunky early concepts, and sometimes they made things worse. There was a period around the end of the 90s where there was the rise of these application servers and web servers that were like a nightmare for me.
And that's where you think we are with AI now. We're at that very early adopter experimental stage, kind of, in terms of development tools.
I think we are. So, of course, as in and of itself, I use ChatGPT all the time now. And I know you use it some because you made a video about it.
I did, yeah.
That was the video that I commented on that got this whole conversation started. And so there's some level of usefulness that it has now. But
I'd characterize that as kind of smart Stack Overflow in my IDE.
well, that's the application that you and I are using it for. That's perhaps the most important one to us at this stage.
Yeah.
And by Smart Stack Overflow, I know exactly what you mean, because a change happened in the way I did software, and a lot of people, I don't know when, maybe 15 years ago, whereas before that, if I ran into some problem, I don't quite know how to write this in my program, I would maybe look in a book about the programming language, or I'd talk to another human that I know that knows that language very well. But that's not the book you'd go to if you were trying to figure out, like, how does, how do I do this other version of a loop where I can have a function in it that's like locally defined or something, and so then came Stack Overflow or the other online discussions and good search, and you search and you find some discussion people have had, or you participate in one if you just happen, in the unlikely event you're the first one to ask that question.
Mm-hmm.
And there it is, and you copy paste and modify a little bit, and the way we coded changed a lot.
Yeah.
But now I don't go to that anymore. I go to ChatGPT or the Copilot or something. Okay, so this is a use we have of it now. But there's another thing, which is building applications with AI components in them. And this, I think, is going to be a very big thing in the coming decade. And I think we're at such an early stage that the early attempts are going to be, in hindsight, very clumsy. And then we'll get experience and we'll build better and better things. It's possible that we'll go down some paths, some blind alleys, as far as we went with the application servers. By the way, I mean, I diss the application servers. I know the people who were, I even know some of the people who were built those things are involved in it. They're good, smart people, but the application servers were not a good technology. And the reason I pick on that one is because they became so dominant for a while that corporations would adopt them as a standard, and you had to use them in the enterprise systems that you were building. And they were so totally an obstacle to getting things done. There came a point where I just said, I don't think it's possible to do domain-driven design on an app server.
Mm-hmm.
Like there was this thing called Unity Java Beans, which I hope that most of our viewers have never seen or even heard of an Unity Java Bean, except as a cautionary tale. But I can see why people invented them. I see that their intentions, but it just was a problem. And so I wouldn't be surprised if we go down paths like that again. So we'll have all kinds of frameworks for dealing with LLMs. Some of them will be really helpful, and some of them will be obstacles, and we'll stumble around for 10 or 15 years, and then people will actually know what they're doing. Yeah, and this presumes, by the way, that we don't have any more really big breakthroughs in the next decade, right? Like, I'm kind of there describing a world in which these language models of varying sizes, we mentioned the LLMs like ChatGPT, but one of the things that really fascinates me right now is like using smaller language models fine-tuned for specific applications. I can just picture a whole bunch of situations where we could have used such a thing in some of the enterprise.
Do you have any examples?
I see, it's so hard because
Let me try it another way around. So one of the places where I think I've seen some of that happening is by virtue of doing this. I play with video editing software sometimes, and the video editing software that I use has some really quite remarkable targeted AI features. So, for example, there's a noise filter that basically you can just record something like this in a noisy background, and you can apply this noise filter, and it'll remove all the background noise, but leave your voice intact and clear, even when the background noise is quite loud and intrusive. And it's really hard to imagine how you do that any other way. And similarly, there are video enhancements. So those very targeted kinds of tools that allow you to do things in a narrow context.
Yeah,
I see creeping in through that kind of route.
absolutely. The thing that we haven't seen yet is people applying this to the kind of domain problems that I typically worked on it. I'm sure it's starting though. I haven't been involved in such projects. If someone's listening who has a project like that, then I'm actually interested. But the thing is that, and these early attempts are bound to be a bit clumsy, you know, and we'll have to learn to deal with things like the unpredictability of the model results, and ways to reduce that or ways to make that be okay. It's going to be a very interesting decade, I think. But that does assume that there aren't breakthroughs that happen that transform everything. Like there are some people who go around talking about how, well, in a few years, we're going to have a superhuman intelligence that will just change it, literally everything about our lives. I kind of don't think that's going to happen, but I mean, my opinion about that has very little to do with whether it happens or not. I think the best thing for me and people like me is to say, well, we can't know what's going to happen, but we do know that we have these tools now. We actually have them. These are not like wild-eyed speculations about the future of AI I'm talking about. I'm saying,
Yeah.
if you take the tools that are out there on Hugging Face right now, if we didn't get anything better than that for the next 10 years, which seems extremely unlikely, but even if you didn't get anything better than that, we could have 10 revolutionary years in which we learn to apply those things in literally every nook and
Yeah.
cranny. But we will have new stuff, of course.
Yeah. Does so you've already said that you don't think, to put words slightly into your mouth, you've already said that you don't think that the AGI thing's going to happen, the singularity is going to happen and it take over the world. But does this make you nervous at all? Because even with the level of technology that we have, I think there are kind of cultural challenges that we're going to face with the easy ability to recreate people and things and so on.
Yeah, I think we should be worrying about that part, right? I think the ability to do a fake version of Dave Farley, that's a real problem that we actually have already. Well, it's going to get worse in the next few years, and society needs to deal with that somehow. Worrying about the singularity, I don't think helps with that. I think it distracts from the actual problems that we are actually going to face. Will we have? I think so. I think singularity, I would assess as very unlikely in the next short time, but remember, my opinion about this has very little to do with whether it happens or not, but I don't think it's very likely.
You weren't sure whether you'd
I
predict
would put
video
AGI in a
phones.
different category than the singularity, by the way. You could easily have AGI and not have a singularity.
Yeah.
After all, we already have lots of GIs and we don't have a singularity. I mean, you're a GI and I'm a GI. So if you stick an A before it, how does that automatically lead to? It does, though. So another thing I'd worry about in addition to the fake Dave Farley's is the disruption to the labor market. I
Yeah.
think that we're going to see a lot of jobs go away and new jobs created, of course, but those will be very different jobs. They're not jobs that are available to the people who are losing their jobs. That's the thing, when people say, well, it's creative destruction and, we'll lose millions of jobs, but we'll create even more millions of jobs. But the trouble is that the people who lost those millions of jobs can't take the new millions of jobs, generally speaking. There's going to be lots of prompt engineering jobs, maybe, but the person who worked at a call center who now doesn't work at a call center isn't going to be able to be a prompt engineer.
Yeah.
Unless it's like the 90s when if you could write a line of PHP that could compile, you could get a job as a web developer. I am not exaggerating. That was kind of a disaster for the field as well, I would say.
Yeah. So how do you see the impact on professional software developers? a tool that's going to use that we're going to use and will change a little bit the way in which we do what we do, or eliminating software development altogether? Where are you on that kind of spectrum?
Well, I'm in the middle of that spectrum, I suppose, because I think it won't eliminate software development as a profession. If they really do create AGI, then I suppose that you could have an AGI do your job or my job. Depending on how you define that, if you have a truly human capable thing, then by definition, it can do things, it can replace a human, any human, I guess.
Mm-hmm.
But I think more likely that the higher level software people are going to have work for, I'm looking 10 years out. I don't know what's going to happen 30 years from now. I probably won't be alive in 30 years, and no one can predict that far in the future. But 10 years is a time horizon where, even though our prediction ability is poor, we have to do our best anyway, because we have to plan and we have to make a choice about what we're going to do, right? So when I say I think there's not going to be AGI, I don't really mean I've done some kind of scientific analysis and concluded that that's not what's going to happen. Although I do think, from my general semi-layman's viewpoint, I don't think that's imminent. I don't think it's as straightforward as, like, just make the LLM even bigger. When an LLM behaves, at moments you have this eerie sense that it's intelligent. And it makes me think that that probably reflects some of how our minds work, maybe more than we like to think, that we have generators in our minds like that. But there are other components, I think. I think it's missing pieces. And I think that some of those pieces will start to come along and we'll get more capable things. And maybe someday they'll have something you could truly call an AGI. I'll bet by that time they have better words for it than AGI.
Yeah.
They'll say, oh, yeah, I mean, early 21st century people had such a naive view of all this. But what we have now is these LLMs, and they're getting better, but also getting smaller. Like, I don't think the whole future is GPT-5. I think that the future will be a range. It's like, look what insects can do with insect-sized brains, right? If we had the insect level AI, think of the things we could do with that.
Yeah, and we're already getting some of that with hardware and software on our phones.
Yeah. I mean, our phones, like, these are going to seem awfully clunky, I think, in just a couple of years. And I mean, like 2, maybe 1 year, because the idea that I have to navigate to an app to do this and that, and I can't just tell my phone what I want. Like, GPT understands enough of what I want, what I mean, that I could just picture just talking to my phone and telling it what I want. Or this stupid, Amazon Echo that I use to turn the lights on and off and find out what the weather is. Well, if that thing weren't so dumb, and I think that will happen, right? But those are the things where you just say, you just take ChatGPT and you integrate it into some stuff. But now let's think about, like, what about people like us who work on systems that have thousands of pieces? And there's the aspect of the tools we use to do that work. Those, we already have at least a couple new tools to do that work with. We've got, but I think the part that excites me the most is the components that we could create to incorporate into those systems. That could be all different levels of language models and other kinds of AIs too. But for me, the language models are the most interesting thing. I mean, after all, right, DDD, I was saying, it's about ubiquitous language. How
Hmm.
cool is it then that when we finally get AI that's worthy of that name, and it turns out to be a language model? I
Yeah.
think that's just good luck. I'm not saying there's anything really profound there, but I'm not saying there's not. But anyway, but you asked me about like, how will it change our work, the tools that we
Yeah.
use? Will it make us obsolete? Will it just be a handy alternative uh, to Stack Overflow? And I said somewhere in between those two things, in ways that are probably hard for me to foresee. But let me tell you, like, how it's been going for me lately, because I do think it's moved into territory that's more than for me, it's already moved into territory that's more than the improved Stack Overflow.
Yeah.
So the thing that I've been trying to learn is fine tuning. So take a language model, maybe a smaller language model that has quite generic training. So it already knows language, it knows English and so on, and then train it to do something specific, something that you
Hmm.
might need a much higher level language model to do if you just throw a prompt at it. But
Yeah.
it's just inefficient to do everything that way. So I've been learning to do this, and there's a whole lot of learning, right? There's just so much. And for me to even just do a little prototype, do a little experiment. And so I'm not very good in Python. I could bone up on Python, but then there's 100 frameworks, including the ones specifically for training these AIs. Now, I
Hmm.
could spend months, grindingly learning Python, learning the various frameworks involved. But what I'm finding is that I can go to ChatGPT and a few other AI tools, and I can get more than just advice about this specific thing or whatever. I can say, okay, now I'm trying to write a uh, script in Python that uses this framework to do this thing. My data frame has this kind of fields in it, and blah, 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 blah. And it will spew out a script with explanatory text. I take the script, I try it out. Now, I'm not just letting it do the job, but I am mostly letting it do the job, because I go
Hmm.
back and I don't even try to really write the scripts by hand anymore. But what I'm finding is that my learning is much faster, because I'm not constantly getting stopped by trivia. The trivia is being handled by a thing that is much more than a improved version of Stack Overflow. It's more like having a pair programmer, except it's not really like having a pair programmer either. Because a pair programmer, like a human one, the interaction would be very different. Um, it's a new thing, and but I use this tool. I'm not collaborating with a human pair programmer, right? I'm using a tool that can generate code in a language that I'm not that familiar with, but I'm getting familiar with it faster than I would have if I had to stumble my way
Yeah.
through. And I'm able to call the right operations in a framework that I've never used before, that I would have wasted a whole day just learning to do a trivial thing, a thing that I conceptually understood already. So I'm not
Yeah.
learning anything important, but I'm just
Yeah.
stumbling for a day on trivialities. So it speeds me through the most boring, non-important learning stuff, and lets me go much faster on the important learning and the important getting able to actually do things. So that in a couple of weeks, I covered ground that I think would have taken me months in the past.
Yeah. I confess that I've largely only played with it so far, but I think I've seen hints of that without really seeing it in the same way that you've described.
I mean,
But
have you gone into an area that you didn't already know yet? because that's
Yeah,
where it really kicked in for me.
it didn't work out for me very well when I did that because it didn't know anything about the area that I was looking at
Oh, okay.
either.
Well, I was in an area that you wouldn't be surprised that it knows a lot, which is
Yeah,
how do you train AI models? And this, it turns out, ChatGPT knows quite a lot about.
yeah. I think it's interesting. As I say, I think I've seen glimmers of that so far, but I need to do some more, more, more work to find those things. I think, but
I must
that's
say,
interesting.
yeah, I mean, so still, as I say, I mean, this is very exciting because I'm not sure, like, would I have gotten, I suppose what I would have had to do in the past is simply say, all right, I need to find a project to sign up to. And I do,
Mm.
I do need a project to sign up to, but just to get through, and there's a kind of a chicken and egg because you want to go to a project and say, all right, well, I already know basics. Like I know enough to be somewhat useful. Like maybe I would have been able to pull it off by just saying, well, I'm a famous guy. I wrote a book 20 years ago and people think I'm pretty good at this. Maybe I could be good at this completely new thing if you give me months to come up to speed. I could have done that maybe, but most people can't do that. I don't want to do that anyway. I want to, you know, learn some basics and also experiment with my own ideas as well.
Yeah, yeah,
I do
yeah.
so many side projects. I always have done side projects.
Hmm.
And my side projects now involve training LLMs and such. Well, LLMs anyway. And
Cool.
and so it removed this obstacle, that I'm not sure I would have gotten quite over that learning.
Yeah.
A learning curve so
I
steep.
know the kind of hurdle that you mean is when you, as you say, conceptually you understand what it is that you want to achieve, and you know that these things are going to do it. You just haven't quite got the, you know, all of the plumbing right or the syntax right at that moment, and being able to get you through that more quickly. I would definitely value that very highly. I was kind of literally looking for that in the little project that I was trying to do. I was trying to do something around writing a test framework that I wanted to do for performance testing, and I thought it might be able to help me do that and navigate adding a plugin um, appropriately. But he didn't know enough about how to do any of those sorts of things, which is fair enough. It's reasonably esoteric stuff,
Yeah.
but
So
but
you ventured into an area that it just hasn't been trained on.
yeah,
Yeah, if it's not in the training set, then that thing can't help you.
yeah.
There is a difference with a human, which is that a human with the training that GPT
Yeah,
does have,
training kind of alongside would be able to have some insight into how to deal this with this
yeah,
problem.
or truly
Yeah,
collaborate with you as you start
yeah,
trying to figure it out for yourself, right? Like if another human who had the knowledge, not because as you say, it's esoteric, but if they had a good base of related knowledge,
yeah,
the two of you would have collaborated. We've gotten that magic that happens sometimes with more than one
yeah,
person, you know. And but you can't do that with GPT. Maybe this imaginary AGI that could come anytime, maybe you can do that kind of sort
yeah,
of extension of what it knows and true collaboration with another mind. Uh, I don't know. I think there's quite a few pieces missing before we have a real AGI.
yeah, yeah. Interesting. I've just noticed the time. I think we should probably think about moving towards wrapping up. I've got a couple of things. So one of the things that we do on our Discord channel is ask Patreon members to suggest questions for the famous people that we talk to. So I've got two or three questions that came from our Discord channel. If you don't mind me
Yeah,
asking those.
let's
So
do it.
so what software books are Eric's top favorite or favorites since Dave gave domain driven design his number one in his video?
Oh my goodness. Yeah.
What's your strongest recommendation for software books that software developers ought to read, apart from
Oh,
yours and apart from mine probably? That would be too embarrassing.
yeah. Okay. So present company accepted. I'm looking behind me because I have a bookshelf back here, and it's so hard to think about stuff like that because I think that the books that influenced me the most were books I read so long ago that whereas the best books might have been more recent ones. I'm gonna duck this question for now.
Okay.
I hate to, but I think I will.
Okay.
It's a good question,
Um,
though.
how much of your domain-driven design book do you feel has become timeless, and how much was a product of the time? You've talked a little bit already about the kind of
Yeah.
the
Yeah, I mean,
language and
this
the
question
examples that
I
you
can
picked.
answer, and I do
Yeah.
think even relatively early on, I was steering people to say, don't get bogged down in like the really long, detailed examples. Like I think it's chapter 7, somehow that rings a bell, but one of the chapters is entirely one worked example. And I think that is important because, one thing I wanted to avoid was having just a floaty, castle of abstractions. But some of the examples are really quite old-fashioned and are not the core concepts, right? Like the fundamentals, like ubiquitous language, boundary context, distilling the core domain, and if you look at it broadly enough, the importance of layered architecture that I was just talking about, those things hold up very well. The discussion of collaboration with domain experts and how these two very different kinds of experts have to kind of interact with each other. Those parts of the book, I think, hold up well. And a couple of personal stories in the book about projects that I was on and how they evolved. I think the point that I try to drive home is how you can't know enough at the beginning to create a good model. So you have to get started fast and iterate, and how that iteration happens, which is partly the collaboration, and also that it's going to be hard and even feel bad sometimes. I think that I tried to convey in the book, how when you're on the right track, it doesn't always feel good because you'll come to a moment, for example, you tell a story in one of the chapters. I think it's, for some reason, I think it might be chapter 8. It's called Breakthrough. But it's a real story from my early career. We were on a project that I would say was pretty much a DDD project, although it was long before I had coined those words. And we were iterating and iterating, and we were so far behind schedule, and we were running into edge cases. And finally, we realized a model that would make a lot of edge cases go away, but would take a profound change in the design. And it was sickening. It was like, oh, we can't get from here to there by improving the design we have. We have the choice between patching up a clumsy system that, will always have a few edge cases, or being even further behind and getting this right. But, when I talk about being behind, we weren't behind because we were doing nice design. We were, I want to make that clear. Anyway, point being, that there are parts that hold up, and a lot of it is around how this happens. But some of the patterns of like I still think distinguishing entities and value objects and events is really valuable.
Hmm.
When I was doing functional programming, where people tend to map like, okay, an entity is you know, an object that has an ID, and a value is an object that doesn't have an ID. But when you're doing functional programming, people will say things like, oh, there aren't any entities there. There's just value objects because objects are immutable. Data structures are immutable in, at least in the language I was using. No, I don't agree with that. The thing about an entity is it's an identity that matters in the domain, a sequence of change where there's continuity. A value object doesn't care about continuity. It just is what it is, and if it changes, it didn't change, it was just
Yeah.
placed. If you're tracking,
If I place an order and I want to find out what the order history is, I want to be looking up the information about the same order.
exactly. Yeah. So the order is an entity, and even if you're in a functional programming language where you don't have an object that you're modifying, which, you know, I would just say is probably not a good practice, generally speaking, anyway, even if you're in another language. I wouldn't have said that in 2003, but I'd say it now.
Yeah.
So yeah, there's a lot in there. I'm rambling now, officially rambling.
So to stop your rambling and to also give you back your evening, I will let's wrap up there. It's been an absolute pleasure. Thank you, Eric. As ever, I've enjoyed talking to you a great deal.
Me too. As usual, it's been really stimulating and given me a lot of interesting thoughts. So thanks for inviting me, Dave.
It's a pleasure. So let me just wrap up. I'll say once again, thanks to our sponsors, Equal Experts. If you've watched this far and caught both Eric and I rambling on about design and all of these other things, then thank you for watching. And if you've enjoyed the video, do hit like. And if you haven't already, subscribe to the channel. Thank you very much.